Hello everyone, welcome back to another video. Today I'm going to be talking about a step 1 question, well, the first question from step 1, 1994. This is a very tricky question because it requires sort of an understanding of what's going on geometrically rather than just sort of, abstractly. Like, it's not like dealing with derivatives where you just need to have an understanding in your head of what's going on. It's more like you need to have a picture of the scenario and then work with that picture to basically understand the geometry of the problem and then try and compute what the problem is asking you to compute. So the first question says, my house has an attic consisting of a horizontal regular base of length 2q and breadth 2p, right? And I guess they're expressing that p is less than q. And 4 plane roof sections, each at an angle theta to the horizontal, show that the length of the roof ridge is independent of theta. Okay, and find the volume of the attic and the surface area of the roof. Fine. So I think the best thing that we should sort of do first is get a diagram. And I think this diagram on the right is really good. I kind of pulled it offline from the student room, but it is a very good diagram of the problem. Because my diagram on the left is sort of not very good because I'm not very good at drawing things like 3D and drawing in general. But you can see what's sort of happening here, right? So we have sort of four sort of plane roof sections. 2 of them are triangular, right? Because you just have like triangles on the ends. And then 2 of them are sort of trapezoidal. So you have 2 sort of trapeziums. 2 sort of trapeziums, however you say it. You have sort of 2 trapezoidal plane roof sections as well. And they all connect along this sort of line, which has length r, which we don't know. But the question is, well, the first part of the question is we need to figure out what r is, and we need to show that r is independent of theta, right? And so obviously theta is just that angle, right? That's made, you can see that theta is sort of drawn in here. I tried to draw it in my diagram, but it wasn't the best. But in the diagram on the right, you can see that theta is just sort of like the inclination of the planes to that sort of ground, right? To the ground. I think that, yeah, that photo on the right, I mean, I couldn't really do any better than that. That's pretty good. So, I mean, yeah, the first place to start, really, is by looking at the diagram on the right and seeing that where our ridge is, right? So we have our ridge. It's sort of halfway along the sort of the breadth of the sort of rectangular base. So, in other words, what we know is that where this r is, if I were to sort of walk from sort of this end of the rectangular base all the way to r in a sort of straight line, I'd be walking along sort of a distance p, right? And so effectively we know that this, and the reason for that is because we know that each of the sort of 4 plane roof sections is at the same angle theta. So if I move my ridge any sort of further along that way, then I'm going to have to compensate by changing my angle slightly, which is not what I want to do. So I need to keep my angles the same, which gives me this symmetry and places r directly in the center of the horizontal rectangular base, right? So we have that. I'm just going to try and do this nicely. So we know that that is p, basically. Let me just see if I can do this properly. So we know that there is p. So this is p. And we're going to label sort of this length here x, right? Because we don't really know what that is. So let me just try and do that. But we want to figure out what that is because we know that if we know that the entire horizontal length is 2q, right? So if I can calculate what x is, right? Then again, due to the symmetry here, I can just do 2q minus 2x, and that gives me r, right? Because effectively r is, even though r is sort of above the ground level, like it's sort of kind of floating in the air if you want, obviously held up by the different plane sections. Even though that's true, if I were to just sort of like bring it down to the ground, right, it would be sort of less than 2q, right? But how much less than 2q? Well, by symmetry, we know it will be exactly 2q minus 2x, where x is sort of this section that we don't know that I'm trying to put arrows on right now. So there you go. So that's x. and we don't know what x is, but we know that well, we can do this exact same argument on the other side, and sort of that length will be exactly the same by the symmetry of the problem. Okay, so that there's going to be x, and on the other side it will also be x, but we don't really need to focus on the other side. And obviously, as you can see in the right-hand diagram here, so they have x and p. They also have some height h, right? So there's going to be a height between the ground level and the ridge, right? Because as I said, it's not floating in midair, but it's sort of like it's sort of lifted above the ground level. So how much is it lifted above the ground level? Well, we don't know, so we're going to label that with h. But the first thing that you do notice is this right angled triangle here, right? So this sort of triangle with lengths HP and angle theta, right? Because we're given that sort of the planes are angled at theta to the horizontal. So we can initially start by considering that. So we consider... So first of all, I guess I should mention, this is going to be for the length of the roof ridge. So length of the roof ridge. So in order to compute this, we're going to have to consider... sorry, give me 2 seconds here. We're going to have to consider the following triangle. So we notice the following triangle. Okay, so the triangle is going to have sort of height h, right? So we're going to have that height h. It's going to have sort of this side being p. Let me see if I can just like put that together nicely. And the hypotenuse we don't know, right? But it's irrelevant for this question, actually. It doesn't matter. For this part of the question, anyway. So we don't know the hypotenuse. So let me just put that all together. Right. But what we do know, right? What we do know is that this side length here is p, right? Just by looking at the diagram on the right. And so I can label that as p. And sort of the other side length, which isn't the hypotenuse, so the opposite to the theta, is going to be, is going to be h, right? Because that's how much our sort of ridge is above the ground level. Right? Okay. Sorry, give me 2 seconds here. Okay. Right, so that's h. And we know this is theta by the question. So I guess the first thing that we notice is that tan theta is equal to opposite over adjacent, so h over p. Which means that we know what h is then. We know the height in terms of p. So h has to be equal to p tan theta. Right. But we can do the same thing, right, with the other triangle where we have x instead of p, right? So in the other triangle, I guess if I say in the other triangle in the diagram, let me just make sure this is working as well. Yeah, in the other triangle in the diagram, sorry, I meant in the diagram. In the diagram, we have so that's going to be h again, but this time this length is going to be x, right? But that should be telling you something, right? Because we know that the angle will still be theta. So what does that really mean? I guess that's really the big question here. What does that mean? So if I just sort of annotate this triangle, sorry, and I'm doing this particularly nicely, but I just want it to be good. Okay, so that's h. We also have that is going to be x this time, right? And again, just look at the diagram on the right and you can see that for yourself, right? But if we calculate x, then we know what the length of the ridge is, right? Because it's just going to be 2q minus 2x, right? Because we can do the exact same thing on the other side, right? It's symmetrical. Right. Okay, so we know that that's going to be x. And we know that this here is going to be h, and this is also still going to be theta. So what we observe is that, again, tan theta this time is equal to h over x. But h is just equal to p tan theta, right? So this is just equal to p tan theta over x, right? So this is obviously telling us, therefore, that p is equal to x. As long as, well, if we divide by tan theta, that's true, as long as tan theta isn't 0. But that would mean that theta is 0, so we wouldn't even have a roof, or theta is 180 degrees. So again, there wouldn't be any roof, right? So that's fine. So p is going to be equal to x, which means, right, so the length of the ridge, so the length of ridge is just going to simply be 2q, which is the total horizontal length, minus 2 times p, since we can do the exact same argument on the other side of this sort of roof here, right? We can literally just do this, we can flip it around and do it on the other side. Okay. So that's the length of the roof ridge, right? And clearly 2q minus 2p, there's no theta involved, right? So no theta involved, which is good, right? That's exactly what we wanted. So that's telling us that we probably have the correct answer. Okay, I guess now let's think about the volume then. So let me just put all that in a box. Did not mean to do that, but that works. Okay, come on. It's being slightly annoying here. This box. Okay, I'm going to take that out. Let me just try to do that again. There we go. Okay, perfect. Okay, so I guess I'm going to go over here and think about the volume now. So what's the volume going to be? Well, I mean, the best way to compute the volume, in my mind, is to split up this shape into 2 smaller shapes that we do know how to compute the volume of. Specifically, you can see here that on the drawing on the right, they've sort of had these dotted lines, which represent sort of this triangular face here. So if I slice the shape there, right, if I slice that sort of roof section there, and I slice it over here, on the other end of the roof, then what I'm going to get, right, is a triangular sort of prism, as well as sort of two end sections, which I can glue together to make a pyramid, right? So effectively, let's see if I can do this. I'm going to see if I can sort of draw out what I mean. So if I just get this sort of point here, sorry, I'm going to try and do actually show you what I mean. Hopefully you kind of see the intuition for what I mean, but I want to do a bit better than that. Okay, so that works. So we can go there. I probably want to make this shorter, like there, and make this shorter over here, and then move this up here, and then we can okay, and then we can sort of put another line in over here, and then do some more lines like this, and like this, and finally like this. So here's our pyramid, right? So this is the pyramid that we make if we sort of, and again, I should probably also highlight that this pyramid is sort of two parts of the roof glued together. So if you think about it, right, and if I cut it along here, if I cut my pyramid along sort of here, then it's going to be symmetrical, right? And I'm going to get my 2 pieces back, right? So that's effectively all that I'm doing here. I'm just cutting it sort of along where those sort of brown triangles are, and then I'm gluing those two end pieces together, and I also have a triangular prism, right? Well, first things first, though. What do we know about this pyramid here? Well, first things first, our length, that vertical length or breadth, I guess, is going to be 2p still, right? It's still going to be 2p. Nothing's changed, right? Because it's still the same as it was on the roof. I haven't really done anything to it, even if I've drawn it like sort of much smaller than the 2p over here. It's just sort of scale problem. But effectively, this is still going to be 2p, right? So we still have this sort of length here is 2p. And we effectively derived, right, that this length here, which was x, was p. So we know that this length here is also going to be p, right? Because it's symmetrical on both sides. You can just use the same argument on the other side. So what that means is that, I also have another 2p sort of for the length of this sort of pyramid section. Right. So that there is going to be 2p. So then, well, the volume of a pyramid is known, and I guess I'll assume that you guys are familiar with it. It's a third times the area of the base multiplied by the height. Right, and remember, the height here is exactly the same as the height would be for sort of the initial roof, right? Because again, we've literally just cut that section out, so the height is exactly the same. So again, we know what h is. H is going to be equal to p tan theta. Right. And so now we can calculate the volume just using that formula. So we have a third times 2p times 2p multiplied by h, which is p tan theta. So that gives 4/3 p cubed tan theta. Okay, so slightly weird, but you know, doesn't have to always be particularly nice at first glance. Okay, so that's what we have for our pyramid. We forgot about the triangular prism, right? So we need to add that in. So I guess we can try and do a triangular prism. Sort of, I mean, I'm not very good at drawing, so this just might be pretty bad, but should be fine. If I can get this. I managed to do it when I was doing the question, so I hope that I can do it here. Okay, so that's that. I mean, I don't know why it's so tilted, that's the only thing. I don't know why I've done that. Sorry, give me 2 seconds there. Okay, so let me just move that like this. And then I guess we can just draw sort of a line going across down there. And we'll do another line going across sort of somewhere over here. So we can go from there along like this. Maybe even like this, I guess. And then we can sort of do another line, which is going to go up from up here along like that. And then we're going to have another triangular face, so like here, and then sort of down here. Let's see if I can get that to work. That looks pretty nice. Not too bad. So let's see if that works. Oh no, what have I done to that? Okay. And then we can extend this, I guess, over here. No, okay, yeah, this is what I want to do. I want to extend it over here, and then do another line up there. Oh my goodness, okay. Is that right? There's something wrong with that. I think I do want this to extend to the other side. So I've drawn this in the wrong place. I do want this to extend here. So I don't want the bottom one to do that. I want my bottom one to be down here. And then I can draw up to it. So give me a couple seconds here. Yeah. Could be something like this, right? So we can remove that. So yeah, what I want is this, right? And then I want to do something like that. That's fine. That'll do. That's a good triangular prism. And so effectively, well, what do we know about this triangular prism, right? So we know that this is still going to be 2p, right? This breadth over here. That is still going to be 2p. Say hello to my cat. Hello, honey. Come on. Come on. Don't step on my stuff. Don't step on my stuff. Come on. So we know that that length is going to be 2p. So we can write that in, right? That's just 2p. I guess the question then is, what is going to be the other length, right? It's not going to be 2p again this time. Instead, it's actually going to be the length of our ridge, r, which we already calculated as 2q minus 2p, right? By the symmetry of the initial diagram and from the first part of the question. So this is going to be just our ridge r, which is equal to 2q minus 2p. And obviously the height is still the same, right? So we still have our height h here, which is exactly the same. So that is exactly the same. Nothing's changed in that regard. So we still have h. So then we can just calculate the area, or sorry, the volume of our triangular prism, right? By just calculating the sort of area of this face and multiplying it by sort of the sort of length of the triangular prism. Okay, so we do cross-sectional area, then multiply it by that length. And so that's going to give us, so the volume, so total volume here is going to be, so the area of the triangle, right? So this is h, and h is sort of that vertical height, right? So that's definitely going to be, the h that's definitely going to be the height that we want to use to calculate the area of our triangle. So we have a half times 2p times h, right? But h is just p tan theta. So times p tan theta. But then we also want to multiply that by the length. So that length is going to be multiplied by 2q minus 2p. Okay. And so now we need to just simplify that. So that's going to be equal to... So this half and 2 will cancel out. But we're still going to get 2p squared tan theta, right? Multiplied by q minus p. So I've just taken the 2 out of the 2q minus 2p. So that's the answer for that sort of volume there. So I guess I shouldn't say total volume. It's sort of more the volume of the sort of triangular prism. So total volume though. Now we're in a position to calculate the total volume. Total volume is just going to be both of those added together. So we're going to do 2p squared tan theta multiplied by q minus p, and then plus 4 over 3 p cubed tan theta. And so that ends up giving us p squared, so then we can factor out p squared tan theta from that. So p squared tan theta, right, multiplied by 4/3 p, add 2q minus 2p, right? And so we can clean up the stuff in these brackets here before we finish up. So that gives us p squared tan theta multiplied by, so sorry, no, not 3q, multiplied by 2q, right? Minus, so 4/3 minus 6/3 is minus 2/3 p. And so that there is going to be our answer, but you could sort of do a little bit better than that and say that that's equal to 2/3 p squared tan theta multiplied by 3q minus p. So that there is our total volume as required by the question. So slightly weird there, but that works. Okay, let's put another box around that. So that's the volume. So I guess all that's left to do, and I don't know why that line is like really wonky, I don't like that. Okay, I guess because I wrote kind of wonky there towards the end. But all that's left to do then is calculate the surface area. So how are we going to do that? Well, if we go back to the initial diagram, right, then what we can see is sort of at this point in time, right, if I want to calculate, this length here, right, I know that, let me just zoom in on what I'm talking about. I know that this length over here, right, if I could just do this, this length over here, that's just going to be our p, right, from earlier on, just like applied to the other side, because that's just x, right? We don't, I guess this would technically also be our height h, right? But that's not the most important detail at the moment, right? The most important detail is this sort of length here, which represents sort of that inclined height of our triangle, right? So if I just draw out that triangle, so for surface area, if I draw out that triangle, then what I notice, right, is sort of as follows. So let me see if I can do that. So I guess I have one side length there, another side length over sort of here, and then you have another sort of incline going up here, right? So, I mean, the details that we care about, sort of the incline, which we know is going to be the angle theta, right, from the question, and this one length that I'm drawing in now, which we know to be p, right? So this length here is p. We know that this incline is going to be theta, and p, and so therefore, so if we want to find out what this length here is, right, which is going to be k, this will make sense later, but if we want to figure out what that is, so if we just label that k, if that's k, then we know that cosine theta is equal to p over k. So p over cosine theta is equal to k, which is equivalent to, obviously 1 over cosine theta is sec theta, so this is just p sec theta. So this k, I can just relabel it as p sec theta, and we'll be using that in the remainder of the question. Okay, so at which point then, that's sort of our height, our inclined height of the triangle, sort of triangular face at the end. Because obviously to figure out the surface area, you have to figure out the areas of sort of the 4 plane sections. So the 2 triangles and the 2 trapeziums, or trapezia, whatever. So effectively, in order to do that, we need to calculate the area of the triangles. And so to do that, we need to do half base times height. And the height will be that incline there, right? Because it's sort of... because if you were to just sort of bring that triangle out, then you would see that sort of the point which sort of touches the very tip of the triangle down to sort of the base length of the triangle. That's just going to be your height. And so in this case, we know that that is just going to be p sec theta. And of course, we know that sort of the base of the triangle has length 2p from the question. So we know that the area of the triangle, so area of triangles on the end. So we can calculate the surface area of the triangles on the end of the roof. And that's calculated as, so how are we going to do this? So we're going to do a half base times height. So a half times 2p, right? So it's going to be a half times 2p, so surface area, is equal to a half times 2p times p sec theta, right? That's sort of the area of one of them, but we have 2 of them, right? We have 2 sort of triangular plane sections on the roof, so we multiply this by 2. And so this gives us 2p squared sec theta. Okay. So that's sort of the first area that we care about. We also need to figure out the area of these sort of trapezoidal sections. That's not too bad though, because, well, if we look at them, we know that, we know that sort of the top length is r. We know what that is, and the bottom length is 2q. So I guess all we really care about then is just going to be that sort of height. But if we look at this diagram over here, and I remove those brown sections, then the height is effectively just going to be the same as, because I have this triangle from before with PH and sort of that other line. So the thing I care about for my trapezium is simply just going to be P sec theta again, right? So actually what I'm going to have, if I go back down, is I'm going to have, so if I just try and draw a diagram over here, I'm going to have a trapezium, so I'm just going to do sort of one of the two trapezium faces, trapezium plane sections, and then you guys can sort of see what I mean. Sorry, it's like my finger just covers it up. It's really annoying to do. Let me see if I can do this on my computer. So, just do it there. I'm just moving myself away. And we're also going to have sort of a line going down from here to here. And then sort of a horizontal line between those two things. Okay. So, well, what do we know about this? Well, the first thing we know, obviously, is that this length here is going to be 2q, right? So that there is 2q. So we can write that in. That there is just simply 2q. As I was just saying, we also know the height to be P sec theta, right? So this sort of height that we care about, right? Because you need the height to figure out the area. So the height that we care about is simply going to be P sec theta. So that there, that's just P sec theta, right? Then the last piece of information that we care about is that sort of top length, which we know to be r, or 2q minus 2p. So that there is r, which equals 2q minus 2p. So again, we can just figure out the total area. So the total area here. So we're going to have our surface area equals a half, right, times sort of the bottom length add the top length. So that gives 4q minus 2p. Multiplied by the height, which is just P sec theta. And then, of course, you multiply that by 2 because we have two plane sections that are sort of trapeziums. So times 2. So this half and that 2 cancel out, and so what we end up getting is just P sec theta multiplied by 4q minus 2p. Right? So now, to figure out the full area, we just add those two contributions together. So the full area, that just gives us 2p squared sec theta plus p sec theta multiplied by 4q minus 2p, right, is equal to, we can just factor out p sec theta, and that just gives us, what's it, 2p, add 4q minus 2p, so those 2p and the minus 2p cancel, and that ends up giving us literally just p sec theta multiplied by 4q. And that is the surface area. So with that, there we go, that's our question all finished. Let me just do this. Yeah, that's all I really have to say. Let's go back and check that was everything. So we need to show the length of the roof wedge independent of theta, done. Find the volume of the attic and surface area of the roof, done. Okay, so that being said, thank you very much for watching, and I'll see you guys in the next video. Goodbye.